In this video, we're going to look at how to find the volume of 3D solids that were created after rotating a two-dimensional figure around a line or around an axis. So before this video, you should have already seen some computer models or some computer-generated pictures to kind of help you visualize what's happening here. So if you haven't watched that video, it's under the video tab. It's the first video of this lesson, so make sure that you go back to it. This is video number 2 of rotating two-dimensional shapes to create 3D figures. So make sure you've watched the first video. So for this video, this first example, we're going to look at how to find the volume of a cylinder that's formed by this rectangle. Now you have to know that if I see this and I'm rotating this rectangle around line L, you have to know that this is going to create a cylinder. So I know that this will create a cylinder, 1, from the previous video, but 2, if I kind of think about this rectangle as it's coming off the paper and then it's going to fall back down and it's going to go behind the paper. So when this comes up and then it lands over here on the right-hand side, it's really going to form another rectangle over here. So I'm kind of thinking about this as a reflection two-dimensionally. But really what's happening is this is coming up off the paper. So I'm going to draw in these curves to represent that 360-degree rotation around the line. So here's my cylinder that's formed. So I see on my cylinder, the height is going to stay 2 inches all the way around, and the radius, what's coming up off the paper and going back behind it, is 5 inches. So when I go to solve this problem, I'm going to write my formula first. So pi r squared times h for the volume of a cylinder. And then I'm going to plug in. So I have the radius is 5, so 5 squared. My height is 2, so I show that. I do not see any rounding directions here, so I'm going to find the exact value, which means in terms of pi. So we are going to only put into our calculator the 5 squared, so 25 times 2 is going to give me 50, and then I keep the pi, so 50 times pi, so 50 pi. My units here are inches cubed. And that's it. So not really a whole lot of new stuff other than the rotation itself. The volume is exactly the same. Let's try one more. So if we look at example 2, we have this right triangle that's going to be rotated around this longer leg or around this axis to get a three-dimensional solid. So again, think about this as it came up off the paper and then it's going to land again on the right-hand side. So you can kind of think about first as drawing this as a reflection two-dimensionally. So this just gets brought up and it lands and then it's going behind the paper. So since it's going 360 degrees, you want to add this curved part to represent rotating 360 degrees. This point up top gets locked in place, so you're not going to see any curved part coming from that. And we can see that we have a cone. So sketch and identify the solid form. Well, I've already sketched it over here. If I want to sketch it again, I can sketch it without the axes. Doesn't really matter though, this you kind of already sketched it, but you get a cone. And we know that we have a radius of 5 for this cone. But notice I don't have the height. I do not know the height of this cone right now. I only know the slant height, this 9 centimeters. So what I need to find in order to find volume, remember you always have to know the height. So volume of a cone is 1/3 pi r squared times the height. I know the radius. I need to figure out that height. And since I know the slant height, you can see that we have a right triangle formed here. So let me pick a different color here. So I can see this right triangle. So what I'm going to do first is I'm going to find the height. So let's put a little note, find height. And of course, if the height was already given to you, like if I knew the height of this triangle, I would be good to go. I would go right into my volume formula. But because I don't, I know the slant height and the radius, I have to find the height first. So we're going to use Pythagorean Theorem. So I'm going to just write a squared plus b squared equals c squared. I'm going to put a right angle in there. So my 5 squared I'll call A. I'm going to put h squared as my B, and 9 squared is the hypotenuse squared. And we have 25 plus h squared. So now we're just going to go through and solve this. So we are going to subtract the 25. So h squared is equal to 56. We're going to square root both sides. And this is not a perfect square, so what I can do, you don't need to worry about trying to do simplest radical form because you're using this into the rest of the problem or into another formula. So it's up to you if you want to leave it as the square root of 56 and plug it in, or if you want to make it a decimal. It's really your call. I would probably personally leave it as the square root of 56 because then I don't have to write a decimal. But if it's easier for you to think about it as a decimal, convert it as a decimal first. Doesn't matter. So now I'm going to go ahead and I'm going to plug into my volume. So volume equals 1/3 pi. The radius we know is 5. And the height is the square root of 56. So if I want to give this as an exact answer, since it doesn't have rounding directions, I would need to simplify, get this into simplest radical form. I'm actually going to change this problem and just have you round it to the nearest, let's say round to nearest tenth, just because I want you to practice putting this all in your calculator. Otherwise, an exact answer would be all of the numbers except for pi. We would need to simplify, do simplest radical form. I don't want to worry about that for right now, so I want to go, let's just round to the nearest tenth. So I'm going to put 1/3 times pi times 5 squared times the square root of 56. And when I do that, I get 195.9127. I'm going to round that to the nearest tenth, so 195.9. Units are centimeters, so it's going to be cubic centimeters. And that's it. So using those ideas, go ahead and try the check your understanding problems and write some key ideas down at the top of the page.